describing our scatter plots. So the other day, the last lesson, we worked out how to do the scatter plots on the calculator and be able to produce them. So remember, a scatter plot is when we have two numeric variables. So you can see in these examples in the picture here, we've got height and weight that we're looking at. They're both numerical, and then the other one's participation rate and hours worked, okay? So let's have a look what we have to do when we are interpreting, because this is all about what we're about. We're about looking at the data and saying what are the trends, what's it showing us. So with a scatter plot, there's the three main things that we talk about. So the first thing is that we talk about the direction. So whether the dots are moving upwards, and that would be positive. So in this first example here, when it's going from the down up, from left to right, that's a positive direction. And then if we're moving downwards from left to right, that's a negative. So that's the direction. The next one is the form. Now we make it very simplistic. It's either linear or non-linear. So linear means that you're following a straight line. So if we have a look here, the form, so you can see the dots, they're not exactly on a straight line, but they are roughly following a straight line. Sorry, the projector's going to catch up in a minute. So, but then if you look at the non-linear, you can see that the dots are going in a curve, and that's where that's what we say is non-linear. So boys in methods, you'll know that there's other formulas that are that. We're just going to simply call it non-linear. And later on, when we have data that's non-linear, we're going to change it to make it linear, okay? So that's all we deal with in general maths. Now, the last thing that we can talk about is the strength. So the strength is how the dots are formed, situated around each other. So if they're very close to being very close to each other, so you can see in this first one, we'd say that's a strong relationship. So this first one here, I'm going to say that's a strong linear. It seems to be following a straight line. This second one here, I'm going to say that would be strong, but I'd probably call that non-linear. So can you see a bit of the curve in there? We would call that one non-linear. So then when the dots get a bit further apart, so you can see here, we'd like to describe that as moderate. And then when they're getting even further apart, like nearly you can't even see sort of the line situation, we're going to call that weak. Now, the way we can rank them, like we know for sure what strength they are, is we can use what we call the correlation coefficient, which is sometimes called Pearson's correlation coefficient, because that was the gentleman that found it, but it's called the R or the R value. So in our calculator, in a minute, we're going to see that it's an R, represented with an R. So the R value, you can only use the R value technically, or use it to describe, if first of all your variables must be numeric. So that means we need to be able to get a scatter plot. They both need to be numeric. And the relationship, the R value, is going on the fact that they are linear. So it would believe that your data is going in a straight line. And also, because of the way it finds the R value, it's worked out in the calculator, and it's working out all the distance between the dots, okay? So if you have an outlier in your data, so say it's well away from everything else, it pulls that and changes that calculation. So it's not very appropriate if you do have an outlier. So sometimes in the question they'll ask you, find the R value, but why is this appropriate or not? And you'll have to note that there's an outlier, and you'll say no because there's an outlier. Okay, so you just got to be wary of that. So you could get a few questions on that, whether it's appropriate. Now, the R value can be any number between -1 and +1. Now, if you have a -1, so you can see down here, the -1 is a perfect negative relationship. So see how the lines are exactly in line. So it has a perfect formula rule for that one. And if you have a +1, it's a perfect positive relationship. And if you have a 0, because you'd be in between, that means you've got no relationship. So you see random, the dots are just everywhere. So up here, I've done a few examples of what like a certain R values look like. So you can see a 0.9, that's going to be a strong relationship. So you can see how they're very close to being near one line. But if you look at this negative 0.3, you can see it's going downwards, but they're very spread apart. So that one would be a weak. So we use this table to categorize. So if your R value is anywhere between 0.75 and 0.99, it would be a strong positive relationship. And then we've obviously got all those categories there. So once you've found your R value, which you use your calculator if it's not given, once you find your R value, you can then describe the strength accordingly to this table. So here in your notes, you've got how to calculate it on the calculator. I'm going to do it now with you here on my calculator. So I'm going to look at this. It says the following data shows the per capita income and the per capita carbon dioxide emissions in 11 countries. So we're going to determine the R value from this. So if I was drawing a scatter plot, I would probably, they haven't really told me, but generally what we would be looking at, we'd be investigating the carbon dioxide emissions in this country, in these countries. So carbon dioxide is going to be our response, and the income those countries earn or whatever will be the explanatory. So let's go to our calculator. So like when we're finding the R, like with our scatter plot, we'd have to put in our list. So I've done it earlier, but you would get them to come up. It's going to come up in a minute. Sorry, this is just a little bit delayed. Okay, so I put in income, and then I'm going to put in carbon dioxide. Wait a minute. 2. Okay. So we pop in those two into lists and spreadsheets on the calculator. All right, once we've done that, I'm just waiting. This screen's not, your screen you're looking at hasn't caught up. I'm going to keep going because it's on here. And I'll keep going and then I'll do it. All right. So anyway, we're going to go to lists and spreadsheets. If you're playing along, you put your lists in, and then while you're in lists and spreadsheets, you can move to a blank square on the side and you can press menu, stats, stat calculation. It's very similar to where we were getting our mean and median, but now when we have two lists, what we do is we go to the A plus BX. So we're actually finding a relationship between those two. So we're going to go that. When you go into that, you then get a menu that says, what is your X list? So you have to select your explanatory variable, and then you get a selection of what your Y list is. So you put your response. So I've put income into X list, carbon dioxide into Y list, and I click OK. Then what you'll do is you'll get all this data. You'll see an A value, which we'll talk about later, a B value, that's the gradient. We use a different letter in general maths. You'll see R squared. We don't want R squared at the moment. We want R. So we see an R of 0.81. So what would 0.81 be in our table? We go back and we can see it is a strong. So that's how we do that. So I'm just going to end this video. And I'll